Hello, everyone. Welcome back. And today we're going to be looking at an introduction to computer vision. So what is computer vision? Computer vision is a branch of science, and it's mainly concerned with processing images or videos and with a bit to extract, analyze, and understand useful information. So that could be from a single image or an image sequence, which is also a video. And computer vision attempts to simulate or copy the human vision system. So it's just a way of replicating the human vision system, how we see and understand and interpret things, and replicate that in computer systems. Computer vision uses various techniques to carry out this aim. Some of them include artificial intelligence and machine learning, deep learning, and many other image processing algorithms that are used to analyze these images. So you look for the scenes, objects within the images, faces in the images, and other content in those images. Now, this computer vision concept has various applications. It has applications in manufacturing where you need to place things correctly on assembly lines. So you can use computer vision to identify the point where it needs to be placed and also identify the object that needs to be placed there. You can use it in medicine for scanning, tumor detection, medical diagnosis. So it can be used to help doctors, or in some cases where a doctor isn't available, you can use computer vision to analyze these images. It can be used in defense and security, surveillance drones. You can use it to identify objects or people in maybe restricted areas. You can use it to identify weapons, or anomaly detection where you identify unusual behavior. You can use it in the automotive industry, like in self-driving cars. You can use computer vision to identify the scene, the roads, the lanes, and stop signs. You can use it to identify obstacles so that the vehicle can avoid the obstacle after detection. You can also use it in security and authentication. So like facial recognition, similar to the ones we have on our phones. The face lock, you can use it for retinal scans where you scan the retina to identify a person, and for biometrics in general. You can use it for social media. So you want to use image filters when you take a picture. That is a form of computer vision. You want to change your background or scene. That is an application of computer vision. And you can also use it in augmented and virtual reality. So in virtual reality, you're creating a scene completely that isn't there at all, virtually, that you can see in screens or VR lenses. But in augmented reality, you have the real scene, but you are trying to superimpose an object onto that scene. So that is another application of computer vision. And this can be carried out through various tasks in computer vision. So you have object detection and recognition, where the main job of that task is to identify objects in a picture or a video and recognize those objects, like a table, like a chair, a book, and so on. Another task is content-based image retrieval. So you retrieve images based on the content within those images. So if you look at our search engine, such as Google, you go to the search bar and you type ball, and Google will bring out pictures of various balls, of football or basketball. All you typed was ball, but based on the content in those images, which were identified as balls, Google decided to bring up those images. Optical character recognition is another task where you have writing in images and the computer vision algorithm extracts the writing just from the pictures so that you can read the writing. Object tracking. In this instance, you have a scene and you've identified an object in that scene, but that object is not stationary. It moves from one point to another. And you want maybe a box or the focus to follow the object as it moves from one point to another. That is object tracking. You have image restoration, which is another task in computer vision, where you have corrupted images or deleted images and you want to restore them from any remaining file or thumbnail that is available. And you have scene reconstruction, where based on just 2D images, you can recreate a 3D scene, an actual scene of an environment that was just captured from those images. Now, computer vision can be achieved using various tools. One of the most common tools is OpenCV, which is an open source library for computer vision. It's used in C++, Python, and MATLAB interfaces. It's quite common. Another one is the Microsoft Vision API, and another one is the visual recognition application by IBM Watson. So let us look at some applications of image processing. So this is quite common. You're driving in a car and you're stopped by a police or traffic operatives. They check your license and registration to see if it's accurate. But with computer applications, there are instances where all they need to mount are traffic cameras. And once it captures a picture of your license plate, it can use optical character recognition to extract the license plate information, run it through their database, and identify who owns the vehicle. So if it's a stolen car, it would notify the law enforcement officials. Or if it's just somebody who has disobeyed a traffic rule, like overspeeding or running a red light, it would immediately notify the relevant authority. You also have instances where you have officials checking your identification to know whether you're actually the person in the scene. But with computer vision applications, you can just have a device that once it scans your face, it can identify who the person is. So, but all these computer vision applications work on images. So what is an image? An image is a figure, or you can call it an artifact. It could be in 2 or 3 dimensions that resembles a subject or physical object. So if you have any figure that resembles something, a physical object or a person, then you can classify it as an image. And it could also be a photograph or a screen display, which is captured by optical devices. So these optical devices include cameras, maybe from your phone or digital cameras, mirrors, where you see your reflection because it's a replication and it's a figure that resembles you, lenses from cameras or glasses, telescopes, microscopes, the human eye, or even water. And this image could be a distributed amplitude of color. So you have various colors representing that image. Whether it's a black and white image or a colored image, it's still represented by various colors. And this can be stored as 2-dimensional or 3-dimensional array of pixels on computers. We'll see what pixels are later on. So there are various types of images, right? The most common classification is 3 types. The first one is a binary image, and that consists of just 2 colors, black and white, which are represented either as 1 or 0. So 0 represents black, 1 represents white. You have a grayscale image, which has various shades of gray ranging from black and white. Then you also have a color image that has a variety of colors that we're familiar with. And these images have various compositions, right? An image can be 2-dimensional, meaning you just have the X and Y axis of the image. It could be 3-dimensional, meaning you have X, Y, and Z axis. So in that case, you're looking at maybe solid shapes or solid images that are in 3 dimensions. And it also be in 4 dimensions. And in 4 dimensions, it means you are considering time as the additional dimension. So in this case, you're looking at image or video sequences, image sequences, where you have them in 3 dimensions, but also in the time dimension. And this is just a representation of the X and Y axis, what we're referring to. It's a look at the coordinate system of how images can be represented. Now let's look at the pixels that we mentioned earlier. A pixel is the smallest element of an image. Pixel actually stands for picture element. So it's the smallest element of an image. And these elements contain numerical values that represent images. And those values can be identified as follows, right? If you're looking at a binary image that is either black or white, then they only have values of 0 and 1. 0 meaning black completely and 1 meaning white completely. If you have a grayscale image that has various shades of gray, then you're looking at values of 0 to 255. 0 meaning completely black, and 255 means completely white. So anything closer to 0 would be darker, anything closer to 255 would be lighter. And this is just a representation of the pixels. You can see that when you capture an image digitally, what the computer sees are tiny boxes, and each of these boxes contain numbers, and these numbers represent the value of the pixel, which corresponds to the color that you're seeing. So it's in the two-dimension X and Y coordinates, X representing the rows and Y representing the columns. So for binary and grayscale images, you only have one box, and in binary images, the box can only carry 0 or 1, or in grayscale images, it can carry values between 0 and 255. Now, you also have a category of color images where it also carries 0 to 255, but you have what we call channels. So you have 3 channels. And usually in color images, these 3 channels, for instance, in the RGB color scheme, you have 3 channels, one representing red, one representing green, and one representing blue. So each of these channels have various numbers ranging from 0 to 255. And when you combine these values, these 3 values, they would give you the color that we want. So if you're looking at the color pink, it would have a red value that could either be 0 to 255. It would also have a green value, 0 to 255, and it would also have a blue value, 0 to 255. And when you combine those 3 values, that would give you the color pink. So the same thing with other colors. If you're looking at the color red, completely red, then it would have a value of 255 for red, but for green and blue, it will have values of 0, 0. If you're looking at green, the green component would have 255 and red and blue would have 0, 0, and so on. So basically, if you have a color, then you have 3 channels, 3 different numbers. When you combine those numbers, they'll give you that color that you're looking at. So, but generally, the total number of pixels in an image can be calculated by multiplying the total number of rows by the total number of columns in an image. And that's why you see some of our camera specifications are calculated in megapixels. How many pixels can the camera capture when you take a picture? So these are just basic fundamental concepts when it comes to image processing and computer vision. Basically, in computer vision, you are trying to understand the values of these pixels and what they represent. In some instances, you're trying to manipulate the values of these pixels to give you something else. So in subsequent sessions, we would see how you can understand the value of these pixels, acquire these values, change them, manipulate them, play around with them to have different outputs as you desire. Thank you.